So welcome you all, and in this video we are going to see about strain gauge. So in the last video we have already seen about, we have started with a variable resistance transducer, and under this variable resistance transducer the first application what we saw is potentiometer, and as a series, so in this video we are going to see about strain gauge. So, what is strain gauge? The strain gauge is an example of passive transducer that converts a mechanical displacement into a change of resistance. Say, for example, if we apply some stress over the material, okay, and because of this stress, there will be some displacement in the particular material. So, this strain can result in the change of resistance, and thereby we can able to measure the electrical, through the electrical property we can able to find out the displacement, how far it has been moved. So this stress and strain always comes in series. So stress is nothing but the force what we applied, and the strain is nothing but because of the force the change in the surface of the body. So in one word, if you say, we can say stress is the cause and strain is the effect. Because of stress, strain happens. So strain gauge is a thin wafer-like device that can be attached to a variety of materials to measure applied strain. So it is just a simple transducer which is used, which can be helpful in measuring the displacement or change in surface of a body. So this strain gauge works on the basic principle, or called this gauge factor. The sensitivity of a strain gauge is described in terms of a characteristics called gauge factor, defined as a unit change in resistance per unit change in length. Say for example, if a body resistance change to the change in the length. So generally it is represented by del R by R divided by del L by length. So R is a resistance, and del R is a change in the resistance, and del L is the change in the length. So this is what being the gauge factor. So based on the gauge factor principle, this strain gauge is basically divided into three. So mechanical strain gauge, then electrical strain gauge, and piezoelectric strain gauge. So and based on the mounting, how we are placing, so it is divided into basically bonded strain gauge and unbonded strain gauge. So here we are going to see about bonded and unbonded. So before that, piezoelectric strain gauge. So this is what normally we used to see, students used to do mini projects with the help of this. So they used to generate electricity, or they simply by pressing. So if you just press, piezoelectric generate electric voltage when strain is applied over it. Strain can be calculated from voltage. Piezoelectric strain gauges are the most sensitive and reliable devices. So we used to keep this, if we just press this, some electrical, due to the piezoelectric effect, some strain is being produced over the surface, and equivalent electrical voltage is being produced. And there are basically two types. One is bonded and another one is the unbonded. So bonded is nothing but we are keeping it, it is cemented to a strained surface. So consisting of a metallic wire, etched foil, and vacuum deposited film or semiconductor bar is cemented to the strained surface. So cemented in the sense it has been laid over, but in unbounded we can able to see it is not bounded, but on one end of the wire is fixed and the other end is attached to a movable element. So we can able to see over here, one end is been attached, the another one is a movable element over here. So if we just stretch over here, then the length or the displacement gets changed, and corresponding electrical property also change. So this is called as the unbounded strain gauge. So there is another one strain gauge that is called as semiconductor strain gauge. So this is also generally used for measuring of small strain. So it is generally, it can be used in the electronic gadgets also, semiconductor strain gauges, so called piezo resistors are often preferred over foil gauges. So foil gauges in the sense, that is piezoelectric gauges. So because they are very very sensitive, but it can able to withstand to some extent. So this is what about the strain gauge. So thank you for watching this video. Have a good day.